So we were asked to find the radius of convergence of this series. So let's start by doing the ratio test. So we can find the limit as n approaches infinity of the absolute value of a sub n plus 1 divided by a sub n. So a sub n plus 1 is equal to 3 times x minus 2, and then substitute n plus 1 where there's an n, so n plus 1 on the top, and we can divide this by a sub n. So that's going to be equal to 3 times x minus 2 to the nth power. And we can see that there's one more x minus 2 on the top than there is on the bottom, so we can simplify to see that this is equal to the limit as n approaches infinity of the absolute value of x minus 2. And this is equal to the absolute value of x minus 2. And by the ratio test, for this to absolutely converge, we know that the absolute value of x minus 2 has to be less than 1. So from there, we can see that negative 1 is less than x minus 2, which is less than 1. So we know that this is centered at 2. And when we simplify even further and add 2 to both sides, we see that x is less than 3. And then we see that 1 is less than x. So since this is centered at 2, we can see that the radius of convergence is equal to 1.